Greetings, everybody. Welcome to the origin of modern astronomy. This is not a history course, but we do talk about some key players and how the Earth-centered universe became the Sun-centered universe and what it means for today. So that's kind of what this is about. And this good-looking young man right here is named Galileo. It's a painting of him doing what he did the first time, using the telescope to look at the sky before anybody else actually did, right around 1610 in that ballpark. So we're going to take a close look at that here. We start with Aristotle, of course, around 350 BC. This guy was the greatest philosopher of antiquity. He knew everything there was to know. He was better in things besides physics, but that's because he didn't really have analytical tools. He was just taking what he had. The trouble was he had so much prestige that his word was basically the law for centuries after he passed away. And it took somebody like Copernicus to finally dethrone that using logic and data. Anyway, Aristotle was about the Earth-centered universe called geocentric. He believed that the Earth did not move, that everything orbited around the Earth, including the planets, the sun, the stars, and so forth. He did, however, the interesting thing was he knew that the Earth was round. So that was a modern view that originated with him and probably other people at that time. And the way they did it, it's suspected nowadays, was they noticed during lunar eclipses, when the shadow of the Earth fell upon the moon, it was round. And that, of course, indicated that the Earth was round likewise, not flat. But nevertheless, even though they knew that, they were confused about the Earth not moving. Everything was moving in uniform circular motion. That survived for a long time. The problem he had basically is in these times, the Greeks were not really scientifically oriented. They were just trying to think of a model, whether it was physical or not, that they could use to predict what was happening in the sky. Now, the problem that the Earth-centered folks had, or one of them, was a thing called retrograde motion of Mars. This is really hard to imagine if the Earth is at the center. In other words, if the Earth is here, it's hard to imagine how this could happen. There were some ideas that Ptolemy had, but they were really stretching credibility, and people recognized it. However, if the Earth is orbiting around the sun, then things get a lot easier to explain. Here's Mars, here's the Earth. The Earth is moving a little faster than Mars in its orbit closer to the sun, and it's like passing a car on the freeway. When the Earth was right around in here and passing Mars directly, Mars appeared to be moving backwards, and that was the retrograde part of the motion. That's exactly what happens when you pass a car on the freeway. Even if that car is doing 70 miles an hour, when you pass it going 75, the car does appear to go backwards. And people realized that this solution required a different model than Aristotle's Earth-centered model. Copernicus. This is one of the greatest names in science and history, associated with the heliocentric universe, that is, the sun-centered universe, where the Earth moves all the time and goes around the sun. And this is known as the Copernican revolution because it took the Earth from the center of all things, it put the sun there, and it had turned the Earth into just another planet that was orbiting around the sun. That was tremendously hard for people to swallow because, first of all, Aristotle didn't think that was the case. And the problem with Copernicus is he still had no physics, meaning that he didn't know what gravity was yet. He didn't know anything about the laws of motion. But this is how powerful his thinking was. He was able to come up with a convincing case for a heliocentric universe based on just logic and a few other observations. He still believed in uniform circular motion. Copernicus, however, let me say just a couple of things about him. He was a celebrity of his time. Everybody knew him. He was an attorney. He was a physician. He was a mathematician. He was an astronomer. He was a linguist. He had connections with the church and everybody else. He was just a well-known figure, and it was just this kind of guy that it was required to sort of overturn or make it okay to think that maybe Aristotle's universe was not correct. But he was still afraid during his life that he would get roasted and toasted because they burned people at the stake for things that they considered to be heresies, and some of these were, and he was genuinely frightened, even given who he was, that he would be burned to death, and so he waited until the end of his life to allow the publication to occur. This is sad. I mean, from a variety of standpoints. He should have been a celebrity making a tour of Europe with his book, signing autographs, going on talk shows, you know what I mean. This should have been a big deal for him. Unfortunately, he didn't get to enjoy it the way he should have, but at least, you know, history has been the beneficiary of his wisdom. Kepler's three laws of planetary motion. Now, Kepler was a contemporary of Galileo, who we're going to get to in a moment. Kepler was a genius in terms of measuring positions of planets and then seeing what they really meant. And this is extraordinary because, again, Kepler had no physics. He had no idea what any of this stuff was being caused by. He simply said, this is what exists in the sky, sports fans, take it or leave it. And in fact, the orbits of planets are known to be ellipses with the sun at a focus. I'll tell you more about that later. Not circles, as Aristotle and Copernicus thought. The equal areas law of Kepler simply, basically in a nutshell, says when the planets are closer to the sun, they move faster. When they're further away, they move slower. That's what equal areas, and that's accurate. And then, of course, there's this very powerful relationship between the period, the time it takes a planet to go around the sun once, and its average distance. All of this was done extraordinarily well by Kepler, who had no idea what was causing it. And it wasn't until Newton came around that it was clear what was going on. Here's Galileo, truly considered the father of modern science. This is extraordinary for a guy who lived when he did, you know, in the 1600s. He is called this because of the central importance of observations for science. He insisted that you really can't know about nature unless you observe it. Today, this kind of goes without saying, but he was the first one to make this case, and his life almost was riding on it, probably was more than he realized. His observations of Jupiter's moons were central to this whole thing because he's found, through his telescope, which wasn't real big, by the way, he found that there were 4 objects that were in orbit around Jupiter and followed Jupiter all over the sky. And he said, wow, that means that not everything in the universe goes around the Earth. See, right away, he's chipping away at this Earth is the center of all things idea. And then he ran into Venus and noticed it had phases like the moon, sort of, not exactly like the moon. The Venus phases conclusively proved, without any doubt, that Venus clearly was in orbit around the sun, not around the Earth. This was really a fatal blow to the classical worldview of how things worked with the Earth at the center and so forth. This got him into a lot of trouble, and he was put on trial. He could have been roasted. Fortunately, they let him off. It turns out that the nice thing was he was put under house arrest for the rest of his life at home. He was already mostly blind because he'd been observing the sun without protecting his eyes. That's something that we should always remember too in here. Never look at the sun without protecting your eyes because you can really hurt yourself that way. Anyway, in 1979, Vatican formally reopened Galileo's case to first of all declare his innocence, and second of all to embrace and endorse his observational approach to understanding nature. That's why he's considered the father of modern science. Isaac Newton. He was born the year that Galileo died, just an interesting coincidence. Newton is truly the consensus GOAT, the greatest scientist of all time. And he is believed that to be that by even modern scientists of the type you'd think might be doubtful, such as Einstein and other people like that, who readily recognize that Newton is the one. The reason is his approach to understanding physical systems was modern in the sense that it combined observations of the physical systems with pretty sophisticated mathematics, most of which he invented, of course. Now, so that was, it's a stunning display, and he did it a long time ago. That's why he's considered the greatest of all time. He needed a mathematics that would help him understand and learn about motions of particles, and so he invented calculus. Everybody in engineering and physics who studies motion mechanics needs to have calculus to really do it well. He also proposed the theory of gravitation that he's probably most famous for, and orbits. He used the law of gravitation to explain why Kepler's laws are the way they are. So this is the perfect, beautiful collaboration, a classic scientific story of how the observations of the sky led to an understanding of what was happening, and then Newton came along and said, here is why it's happening, because gravity is operating on these planets. Also, Newton's laws, 3 laws of motion, are exquisite, still in use today. The idea of inertia, everybody knows what that is pretty much. The famous F equals ma law, force equals mass times acceleration for a particle. That's probably the most famous equation in all of science, I would guess. And then equal and opposite forces law, which simply says that, let's say you're leaning against a wall, just put it that way. And the force you're exerting leaning against the wall is exactly the same as the force that the wall is against you, except it's in the opposite direction. Very profound stuff. It seems commonsensical, but the more you look at it, the more it's not. It's an amazing intuition that he had about physical systems. As you know, seeds usually has some interesting common misconceptions in these chapters, and this one is no exception. When Columbus in 1492 came across to North America and South America and Central America, he had to get Queen Isabella to support his voyage. Incidentally, he didn't have to convince her the Earth was round because they both knew it. Remember, Aristotle knew it as well. They knew it was not flat. In those days, people who were not astute or didn't know what was going on thought that you'd come to the edge of the Earth and fall off. I've never been able to figure out what they'd fall off into, but that's neither here nor there. But he did have to convince her that the Earth was small enough so that this voyage could succeed. For example, if North America or in South America and Central America did not exist, that means he would have sailed across the Atlantic and then have to go the rest of the way to Asia, across the Pacific. Chances are he would not have survived that. So he was lucky that the Americas were here. He didn't know they were here. Now, we mentioned Galileo getting in trouble with the Inquisition for his belief that the Earth moved, but that wasn't the half of it. The big deal was this idea that observation was the way you learn about nature. And that meant that authority figures of any kind could not wake up one morning and say, this is the way the universe works because I say it is. And in reality, a scientific approach insists that you use observation to find out what's really going on. They didn't like that, but fortunately he wasn't killed. He was allowed just to retire to his home. The third one, some people think that the moon has no gravity on its surface. I've known people who think that. It's easy to get confused about that one too, by the way. Remember, the moon has gravity, but it's low. It's like 1/6 g. If you've ever watched, I'd recommend you watch a YouTube video of the astronauts walking on the moon. You'll see that they actually can jump quite a ways, and it's because the gravity is only 1/6 on the moon of the Earth's gravity, which is 1 g. Okay, that's it for history of modern astronomy. We'll see you next time.